When creating a user-defined procedure, Skill provides a mechanism to allow optional arguments, keyword arguments, and an arbitrary number of arguments. To define optional arguments, we use the add optional option in our function definition. Let's look at an example that we had used from a previous training byte. This example function definition requires exactly 4 arguments that will be passed by position and by value to the variables x1, x2, y1, and y2, which may represent 2 points. The delta x and the delta y of the 2 points is saved, and the sqrt function is used to calculate the distance between the 2 points. First, let's note that we made a rather preposterous choice for the order of our arguments. If the 4 numbers are to represent 2 points, it would be much more natural to supply the arguments as x1, y1, and x2, y2. So we'll change the order of our arguments to make a better example. We'll also make the second point, x2, y2, optional. So, if the second point is not supplied, then the function will return the distance of the single point from 0, 0. To define optional arguments, we use the add optional option in our argument list, and all the arguments after the add optional keyword will be optional. We currently are not supplying a default value for our optional arguments, y1 and y2, so they would default to a value of nil, and our arithmetic operations would throw an error. We can define a different default value for our optional arguments by supplying the optional arguments as a 2-member list. The first member of the list is the optional argument, and the second member is its default value, which we will set to 0 for both x2 and y2. If we save and load our file, we now see that if we supply 4 numbers to our distance function, it will return the distance between the 2 points. And if we supply only 2 numbers to our function, then it will return the distance of the single point from 0, 0. The at key option is another way to define optional arguments, but is keyword-based rather than position-based. Let's change our example to use the at key option instead. x2 and y2 now become keywords that are supplied during the function call, and they will have a default value of 0 if we do not supply the keyword and value. Let's load the function, and to run the function on 2 points, we need to supply the x2 and y2 keywords using the question mark marker and then the value. Notice the keyword arguments are not position-based, so we supply the keyword arguments in either order, and based on our definition, if we do not include the keyword arguments, they will default to a value of 0. Finally, we could also have an arbitrary number of arguments. The @rest option allows us to define a variable name that will hold a list of all the arguments that are passed. For our example, we will continue to have x1 and y1 be required arguments, and we'll use the @rest option, and assign all other arguments that are passed to our function to the variable args as a list. In the simplest form of our example, we can then use the nth function to get the values of x2 and y2 from the args list, and use them to calculate our distance. There are 2 required arguments, and an arbitrary number of arguments that can be supplied after that. If we do not supply any arguments after the first 2 required arguments, then our function errors, because args is nil or a list of 0 items, so the nth of args returns a nil also, and our arithmetic operations error out. We'll add a when block in, so if less than 2 optional arguments are supplied, we calculate the distance from the first point to 0, 0. The number of arguments after the first 2 required arguments is arbitrary, and right now, if we supply 6 arguments for 3 points to our distance function, the extra arguments after the 4th argument are completely ignored. Let's set up a counter, and initialize a total distance variable, and then create a loop to loop over the list of optional arguments that are passed, so we can return the total distance between all the points supplied to our distance function. We'll extract an x and y from the argument list and continue to calculate the delta x and delta y, and then add the distance between the 2 current points to our total d distance. Before starting the next iteration of the loop, we'll set x1 and y1 to the current x2 and y2, and increment our counter by 2, since we are iterating over a pair of items at a time. If our counter is less than the length of our argument list, then we'll continue to iterate until we exhaust all the items in the list. We actually compare our counter to 1 less than the length of the list, so we don't error if somebody supplies an odd number of arguments. If an odd number of arguments is supplied, then the last argument is ignored. After our while loop, we evaluate the total D variable, so this becomes the return value of our function. If we load the file, we can see that we could supply one xy location to calculate the distance from our point to 0, 0, or we can supply an arbitrary number of points, and calculate the sum of all the distances between all the points. In summary, the skill programming language provides a mechanism to allow optional arguments, keyword arguments, or an arbitrary number of arguments.